Alright, hi everyone, welcome to my YouTube channel City of Electrons, and in this video we are going to talk about the properties of transfer function, just like a continuation of the previous video. Okay, like I said, all the videos in this playlist, they are linked. Because it's one semester work. Okay, one semester work, so they are all linked. So just as much as you can watch on the previous one, and like that. So from the previous one, we talked about this. Transfer function. That's the last part of last video. We said that this. Let me take that out. We said that this is the transfer function, y of s over x of s. Bear in mind that transfer function is simply output over input. Okay, that's just it. Ratio of output to input. Now, being that h of s is expressed in the form m by n or m over n, where m and n are polynomials, h of s is a rational polynomial. Now, look at this guy. Okay, it's expressed as something over something. So, we can say m over n, where m, which is what we have on top, numerator, is a polynomial, n is also a polynomial. So when you have, this is a rational expression now, like this is something like ratio. Okay, so something over something, then what we have as over something, they are polynomials, a polynomial and a polynomial. That means this expression is a rational polynomial. Okay, now when we say polynomial, we just mean a mathematical expression that has coefficients, variables, and operations of multiplication, addition, and subtraction. Okay, except division for a reason. So just know that expressions with coefficients and variables. Okay, and sometimes we even have, in fact most times we even have these powers, some to the power of 3, to the power of 2, 4, 5, and so on. Okay, now with that being said, let us consider some properties of rational polynomials, because we have just established that h of s, transfer function, is a rational polynomial. We have explained that just now. So what are the properties of a rational polynomial? Knowing the properties of rational polynomial is knowing the properties of h of s. So one of the properties of a rational polynomial is the coefficient of the highest polynomial must be 1. The coefficient, of course, coefficient is just the number close to, let me use the word close to, the variable. So they just said the coefficient of the highest polynomial must be 1. What's the highest polynomial here? This is the highest polynomial. This polynomial is higher than this polynomial. Why? Because of the power. The highest power here, 1. In fact, there's no s here. Okay, all this is a constant. This is a constant. There's no variable here. So here we have a variable, and here we have a variable. Okay, the coefficient of this variable is a. Here there is no variable s. Here the coefficient of this variable s is 1, invisible 1, of course. Okay, so that's the first property. The highest polynomial must be, the coefficient of the highest polynomial must be 1. M must be less than n. M must be less than n. That means the polynomial you have on top must be less than the polynomial you have on under, that's the denominator. And how do you know which one is less? Like I just said, by the power, by their power. Okay, so by their power you know which one is more, which one is less. Okay, so when m is less than n, we say the transfer function is strictly proper, Okay, but if m is less than or equal to, that means their powers are of the same. If we have s raised to the power of 2 on top here, that means their powers are equal. So if m is less than or equal to, we say the transfer function is proper. It's proper because it's less than or equal to, so it's proper. But if it's just less than, it is strictly proper. But if m is greater than, man, that's not proper. We say that transfer function is not proper. There's an example my mother gave me in terms of fraction. Okay, she said if you have a smaller number on top being carried, this is just like a nice way to express it. Let's say someone of 4 years is being carried by someone of 19 years old. Yeah, it makes sense. It's proper. Okay, it's proper for someone older, someone stronger, okay, to carry someone that's younger or has less mass compared to the other person. And my mother said it is not proper for someone bigger to be carried by someone less in terms of mass. Okay, so this is just like saying small pikin carry big person. It is not proper. It's not proper. So this is how it's just a nice way to recall, to bear in mind that what you have on top, your polynomial on top, in this case now we are talking about polynomials, not just ordinary, not just single integers or numbers. We're talking about polynomials now. So if the polynomial we have on top, that's the numerator, is less than the denominator, that is strictly proper, very okay. But if the m, which is numerator, is less than or equal to, it's almost like less than or equal to, we can say it's proper, but not strictly proper. But if m is greater, that is the numerator now is greater than denominator, oh boy, it is not it is not proper. Okay. Number five, the Hughes property. Now, the order of the transfer function is the order of the denominator polynomial. Look at this. So this is our transfer function now. What is the order of this transfer function? How do we know the order? Look at the denominator polynomial. What is the order here? Order will mean power. So this s is raised to the power of what? 2. That means this transfer function is of order 2 because the power of the denominator polynomial is 2, or the order of the denominator polynomial is 2. That's how we know the order of the transfer function. Okay, so yeah, so we'll just stop here in this video, and in the next video we'll talk about how we can express transfer function, okay, and then what we mean by the roots, poles and zeros. We'll be very fast with that. Okay, so this is just it for this video, and this video we just talked about the properties of polynomial, properties of rational polynomial, which is our transfer function. Okay, so of course, like, share, subscribe, comments, and I'll see you in the next video. Thanks for watching, and bye for now.